Okay, welcome back. We are ready to start chapter 10, and chapter 10 is all about circles. Before we start chapter 10, though, it's kind of important that we review a couple of algebra skills, and one of those algebra skills that we're going to review is multiplying here. And I'm going to show you two different ways on the first one that you can multiply, and then I'm going to show you just the one single way on some of the rest of them. So if we want to multiply, here I have two binomials. That's x plus 5 is a binomial. Bi means 2, so there's two terms in there. And I have x plus 5 times x plus 2. One way to think about it is if you are multiplying, you can multiply using the FOIL method, first, outside, inside, last, or sometimes it's called the double distribution method, where you take the first term here, I've got x, and I'm going to multiply it by everything in the second factor. So I'm going to take x times x, and I'm going to take x times 2. So that will give me x times x is x squared, plus 2 times x is 2x. And now I'm going to take that second term here, the 5, and I'm going to multiply it by everything also. So I'm going to have 5 times x is 5x, and 5 times 2 is 10. So then I have x squared. I can put together my two middle terms, which are 2x and 5x, which gives me 7x plus 10. And keep in mind, the rest of these are not like terms, okay? Which means you can't put the x squared together with the 7x or with the 10. So it's going to be all three of those terms here, okay? So the other way you might have remembered from Algebra 1 is what's called the box method. And in Algebra 2 next year, you'll use the box method a lot. So I want to refresh you on how to do this also. So when we have x plus 5 times x plus 2, we put x and positive 5 on the outside of our box, and we put x and positive 2 on the inside of our box. And then we multiply. We say x times x is x squared. X times 5 is 5x. X times 2 is 2x, and 2 times 5 is 10. As you can see, we get the same answer. It's just two different ways to go about it. And then what you find is that these two right here that are diagonal from each other are actually the like terms. And so you're still going to be left with x squared. That 2x and 5x is 7x plus 10. And either way of these, either method here will work. It depends on how you want to show your work, how you want to multiply it out, whichever makes more sense to you. You can do it however you want. But you just need to make sure that as you're doing them, you're getting the same answers as us. All right, so let's look at another one here. I'll do it both ways again. So I have x minus 4 times x plus 3. First, I'm going to take my x, and I'm going to multiply it by each part over here. So I'm going to have x times x is x squared, x times 3 is 3x, and then I'm going to take that negative 4 and multiply it by both. Negative 4 times x is negative 4x, and negative 4 times positive 3 is negative 12. Okay, so then those two terms in the middle are going to be like terms, and we would say x squared. 3x minus 4x is minus 1x minus 12. And a quick way to think about it, if you wanted to do the box method, make it a 2 by 2 box, and we put x and negative 4, and then we have x and positive 3. Again, x times x is x squared, x times negative 4 is negative 4x, 3 times x is 3x, and 3 times negative 4 is negative 12. So again, we're going to end up with the same answer, which is x squared minus 1x minus 12. Same answer, two different ways to get there. So let's take a look down here. Number 3 is going to be the exact same idea. If you want to pause the video and work whichever way makes more sense to you, when you get done, you should get x squared minus 7x plus 6. So if you want to pause and try either the double distribution FOIL method, or if you want to try the box method on your own, go ahead and try that. And then the last one here, I just wanted to point out that x plus 7 squared is not just x squared plus 7 squared, which is not just x squared plus 49. Keeping in mind that x plus 7 squared is x plus 7 times x plus 7, and you're still going to get 3 terms in your answer. So if you want to have a little extra practice here with either of those methods from before, you can pause the video and either try the box method or the FOIL method, and you would have x squared plus 14x plus 49. Please make sure that if you are not understanding how to multiply, we are not really going to use the multiplying a lot today in our homework and stuff, but we will on our next homework assignment. So I just wanted to start getting you to remember the idea of how to do multiplication. So we'll kind of keep moving on here. All right, so I told you we were going to be working with circles, and a lot of what we're going to do is not just circles, but then segments that are related to the circles. And all we are going to do here is, if you look, it's a circle and it's got some segments on it that make a triangle. Okay, so we're just going to focus on what we do know. The directions say to find the radius of the circle using the Pythagorean theorem. Okay, well, let's focus on what we do know about the Pythagorean theorem, and that is if we have a right triangle. Okay, so here's my right triangle. Here's 1 and 2. Those are the 2 legs. That's going to be your A and B. And then the side across from the right angle, the hypotenuse, is going to be your C value. And just remember that the Pythagorean theorem is a squared plus b squared equals c squared. Remember, we said the legs are a and b, so that's r and 12. So we would say r squared plus 12 squared equals 13 squared. Okay, so then we just need to use our Pythagorean theorem to figure it out. We would get r squared plus 144 equals 169. If we subtract 144 from both sides, we get r squared equals 25, and our radius is 5. Here a little bit later today, we're going to learn some vocabulary about the names of these segments that I have highlighted in red and blue and stuff like that. But for right now, we're just going to do what we know, which is the Pythagorean theorem. So if we look at the second one, we have r and 18. Okay, well, here's our right triangle. These are the 2 legs, so that's going to be our A and B. And then the side across from the right angle, the hypotenuse, is our C. So we are going to say that r squared plus r squared equals 18 squared. So let's keep thinking here. All right, I have r squared plus r squared. Well, if I'm adding r squared plus r squared, that gives me 2r squared equals, well, 18 squared is 324. Well, I don't want 2r squared. I just want to get that r squared alone first. So we're going to divide by 2. And we end up with r squared. Let's divide that out. 324 divided by 2. Okay, and 324 divided by 2, it looks like is 162. And we need to take the square root of both sides. So r is the square root of 162, which if you take the square root of 162, I don't know what that is off the top of my head. We'd have to have a calculator to figure that out, but you guys can go ahead and figure that out in the calculator. Number 3 is a little bit trickier, so be careful when you're doing number 3. Okay, so if we look, it's the same idea though. Here's our legs, here's one of our legs, and here's the other leg. So r and 8 are the 2 legs. The hypotenuse is this whole length. Well, the inside part is r, the outside part is 4, which means the hypotenuse is going to be r plus 4. So we have to be careful with that. So my Pythagorean theorem is going to be r squared plus 8 squared. Those are my 2 legs, my A and B, equals r plus 4 squared. Okay, so as we are working through this here, r squared is just r squared, and 8 squared is 64. When I multiply r plus 4 squared, that's r plus 4 times r plus 4. I'm just going to do the box method over here. So I have r plus 4 and r plus 4. So I'd get r squared and 4r and another 4r, and 16. So I would have r squared plus 8r plus 16. I need to get r's by themselves, so I'm going to subtract r squared from both sides, and that's going to get rid of those, because if you subtract r squared minus r squared, there's nothing left. And then that gives me 64 equals 8r plus 16. Now I need to get r by itself, so I'm just going to subtract 16 from both sides, and I get 8r over here, and I get 48 over there. Oops. And I need to divide out my 8, and I get that r equals 6. Okay, so if we go back up, and we just want to make sure that our answer makes sense. So we go back up, if we put 6 in up here, we get this side would be 6, and 6 plus 4 is 10, which that answer does make sense because we know our hypotenuse has to be the longest side. Okay? All right, so this chapter has a lot of vocabulary, and what we have here are some of the more common vocabulary words that you're going to hear a lot of. Okay, so what we have on the right is a diagram showing what all of these look like, and on the left we're actually going to just write out some definitions in words of what they actually mean. So you need to become familiar with these because we are going to use particularly radius and tangent a lot. Okay, so if we look over here at our diagram, okay, I'm looking first at the word chord. Okay, so a chord is this right here. The first thing that I notice about a chord is that it is a segment. It has two endpoints. Okay, so when I describe what a chord is, I'm going to say it's a segment. Oops, I need to have a pen. A segment. And then I need to think about where its endpoints are, with both endpoints on the circle. Okay, so here's my chord. Here's one endpoint. Here's the other endpoint. And it goes, notice that a chord goes through the circle. Obviously, if it has endpoints, two endpoints on the circle, it goes through the circle. Okay. A secant, okay, if you look at what a secant is, let's find that one over here. Okay, this is a secant. And if you notice again, notice that a secant is not a segment. It doesn't have endpoints. A secant is a line. Okay, and then we think about where its endpoints are. Well, it doesn't have endpoints, but it intersects the circle. It's a line that intersects the circle at exactly 2 points. Okay, so it intersects the circle once, twice, but it's a line, so it keeps going through the circle. Okay, tangent, okay, let's find tangent over here. Tangent, that's this line out here. And we did just talk about tangent, remember, in our last chapter with right triangles. This is a different type of tangent. Okay, so this tangent, notice first of all, a tangent can technically be a line or a segment or a ray or anything like that. But a tangent here is going to be, in this case, what this diagram is it's a line, zoom in here, that intersects the circle exactly one time. Okay, so our tangent line is going to be on the outside of the circle, and it intersects it exactly once. And if you zoomed in here really super duper close, you would see that it is only one place that that tangent is actually intersecting that circle. It's kind of like sitting a ruler or something on a basketball, and it only hits the basketball at one specific spot. It's the same basic idea. And I would hope that these other two, radius and diameter, are vocabulary words that you have heard before. Okay, so a radius and the diameter. Okay, but if we're talking about in terms of circles and things like that, a radius is a segment. Okay, so if you notice over here, here's my radius and here's my diameter. And you guys know that a radius is half the distance across a circle, right? You probably have heard that before. But when we describe it for this chapter, we're going to say a radius is a segment. Okay, so it has two endpoints. So it's a segment with one endpoint on the circle and the other at the center of the circle. Okay, so then if, thinking logically, a radius goes from the center to the outside. It's basically half the distance across. A diameter is technically, it's a segment, okay? So it's a segment, and it's also technically a chord. Okay, so a diameter is also a chord. So it's a segment with endpoints on the circle. And what makes it different than just any old chord is that it goes through the center of the circle. Okay. And really there's probably one other vocabulary word that we could add here, okay? And it goes along with tangent, okay? And that is what is called the point of tangency. Okay, that's one more. And basically where my green dot is right here, that's my point of tangency. It's the point where the tangent line intersects the circle. So it's the point where the tangent line intersects the circle. And remember, if it's a tangent, it only intersects once because it's only hitting that circle exactly one time. Okay? All right, so let's go ahead and use some of these vocabulary words. All right, so we have a diagram on the right, and we just want to know, is it if it is a radius, chord, diameter, secant, or tangent to the circle. So let's look here. Number at letter A, it's AC. And notice it is talking about segment AC. Okay, so we know that it's a segment. And if we find AC, here's A and here's C. We're talking about that piece right there, which goes from the center to the outside. So we know that that has to be a radius. Okay, and then the next one, we're looking at AB. So if we have here's A and here's B, those points are both on the circle and it goes through the center of the circle. So the most specific name we would have for that is a diameter. Although technically we could also call it a chord. Okay, and then letter C is we have ray DE. So let's find DE. Here's D. E, okay, and remember I said that a tangent could be a line, a ray, a segment, anything. Well, if we have ray DE, it's on the outside of the circle and it is touching it at exactly one place, so this is going to be a tangent. And then line AE, let's find line AE. Here's A and here's E. If we're talking about this line, notice the line goes all the way through the circle and it has no endpoint. I mean, it intersects the circle at two places, which means it's going to be a secant. If it had been segment AE, or excuse me, segment A, not AE, AG, just looking at another option, if it was talking about segment AG from here to here, that would have been a chord. last couple of questions here. So here we have a diagram. What vocabulary word, again, the secant, tangent, ray, chord, all those, describes each? So we're looking at segment AG. Oh, I think I just talked about this at the end of the last slide. If we look at segment AG, notice it's a segment because it doesn't have arrows on it. AG goes through the circle, and it has two endpoints, which would make it a chord. And then if we're talking about segment CB, goes from the center to the outside. That's like halfway across the circle. That's going to be a radius. And just for future reference, just in case you ever see this, the plural of radius is radii, R-A-D-I-I. That's the plural of radius. So just an FYI for you. All right, if we want to find a tangent line, okay, we need to find the line that is on the outside of the circle that intersects it exactly one time. So let's get rid of my stuff here. So we could name this tangent line several ways. So we have this line on the outside. Remember, it takes 2 points to name a tangent line. And when you go to do your homework today, we are going to put them in the letters in alphabetical order. So one tangent line, we could say, as long as we have that line over the top, we could say BD, okay, because that's 2 points on that line. We could say it could be line BE, because that also, that's 2 points on there. We also could call it line DE. So there's several answers that would be correct here, and several ways to name it. But when you go to do your class kick later, they need to be capital letters and they need to be in alphabetical order when you name them, just to help you get them correct on the first try. So if we were talking about a tangent segment, okay, if it was a tangent segment, it would be any one of these from up here, except it would not have the line over the top, it would have a segment over the top. And then the point of tangency, remember, is that point where the tangent line intersects the circle. If, in this case, the point where it intersects is at point B. Okay, so good luck, and you have a class kick that you need to work on once you finish taking the notes.